Today's lesson is based on physics. We are going to look at electric circuits. This is lesson 102. Let us start. In the previous lesson video, we looked at the basics, and then we also looked at problem solving questions whereby we were calculating different types of resistance on different types of electric circuits. Remember, we have parallel circuit and series circuit. Now in this lesson video, we'll be looking at the remaining physical quantities, which is potential difference and the current. For a better explanation, we're just going to look at questions, how to answer them, how to apply the equations that we talked about in the first lesson video. Now, before we can look at the examples, you need to be familiar with this equation. It's actually R is equals to V over I. This is Ohm's law, whereby R is the resistance. It's measured in ohms, and then V is the potential difference. It's measured in volts, and then I is the current, which is measured in amperes. So today we are going to apply this equation in most of our examples. Let us actually start with the questions. The first question, we look at this particular circuit. We have one resistor, which is a resistor R, and then the resistance of this resistor is 10 ohms, and then we can see that we have a voltmeter connected to the 10 ohms, and then the ammeter, which is connected in series with the circuit, it registers 4 amperes. Then the question, calculate the reading on voltmeter. Now we need to understand something. We need to understand the flow of current. There's 4 amperes. Remember, the battery consists of 2 terminals, which is positive terminal and negative terminal. The flow of current moves from positive terminal to the negative terminal. Now, looking at this flow of current, there is no branch or any other resistor before this 10 ohm resistor. So it means the current flowing through this 10 ohm resistor, it's 4 amperes. There's no division in terms of this current. So focusing on this 10 ohm resistor, we can say the value of current here is 4 amperes. So in this case, you can quickly use Ohm's law. We are only focusing on the 10 ohm resistor. So we have the resistance, which is 10 ohm. We have the current, which is 4 ampere. Then we are looking for the voltage. Remember, voltmeter measures the voltage. So by calculating the voltage, we are actually calculating the reading on the voltmeter. So substituting, we have 10 ohms, which is equals to V over the current is 4. Then we can just multiply by 4 both sides. We know that this will result into 1 multiplied by V. We have V is equals to 4 multiplied by 10, it's 40 volts. Then the reading on the voltmeter, it's 40 volts. Let us look at another question. This is our second question. Remember, in order for you to actually master this, you can simply pause the video, you work out the questions, and then you play the video. Now the first question, it says calculate the total current of the circuit. And then the second question, calculate the potential difference across R1 and the potential difference across R2. Looking at the diagram of the circuit, we can see that we have a 12 volt power supply, and then we have R1 which is 2 ohms, R2 which is 4 ohms. Now calculating the first question, we need to understand something. Based on the first lesson video, we know that in series the equation to calculate the current, it's I total equals to I1 equals to I2, provided we have only series connection. And then for potential voltage, potential difference, it's V1 plus V2 plus V3. Now looking at these equations, I total is equals to I1 equals to I2 equals to I3. It means the current through the first resistor, or R1, will be equals to the current flowing through R2, which will be equals to the current flowing through the whole circuit, which is the total current. Now why is it like that? Now remember, we have positive and negative terminal. When the current flows from the positive to negative, before it reaches R1, there is no branch, so the current is not divided. It means the whole of this current from the battery will flow through R1. As we can see that through R2 there's no branch also, so it means we are still going to have the total current flowing through those two resistors. Now for potential difference, the sum of the voltage or the potential difference across R1 and R2 will be equals to 12. V total is equals to 12, and then V1 is the potential difference across R1, which is not equals to 12. It doesn't behave like current. This is what is happening. It means when the 12 volts is traveling from the voltage, the battery, some of the voltage will be left in R1, and then the remaining voltage will go through R2, and then when you add the two voltage, the two potential difference, they will give you the total of 12 volts. I hope you can see that. Now looking at the question says calculate the total current. So it means for us to calculate the total current, we need the total voltage, we need the total resistance, so that we can calculate the total current. Ohm's law is applicable to many questions. Now the 12 volts is our total voltage from the battery, directly from the battery. Now we need to calculate the total resistance. How do we calculate? Since this is series connection, we are going to use RS, or R total, is equals to R1 plus R2. The equation from the first lesson video. RS is equals to R1 is 2 plus 4, and then this will give us 6 ohms. That is the total resistance of the circuit. So it means for the total resistance, we actually have 6. So you have 6 ohms. Now we are looking for the total current. The total current is the one which I marked with a pink color, the one which will go through R1 and R2. So how can you calculate it? We are going to use Ohm's law. R total is equals to V total over I total. R total we have 6 ohms, V total we have 12 over I total. Then we multiply both sides by IT, which is the term causing the fraction. This will get rid of this, and then we have 6 IT is equals to 12. Then from here we can divide by 6 both sides. I total is equals to 2 amperes. So this is the current which flows from the battery, which flows through R1, which flows through R2. So in this case, it is simple for us to actually calculate the second question. The first question, we find that the answer is 2 ampere. So for the second question, which is V1 and V2, focusing on resistor number 1. Resistor number 1, we have the resistance, which is 2 ohms. We have the current, which is 2 amperes. Now we know the reason why we say I total, because the current which flows from the battery directly from the battery will also go through R1. So we are looking for the potential difference, which is V2. Then we can use Ohm's law again. R1 is equals to V2 over I total, or I2. So R1, we have 2 ohms, is equals to the potential difference you are looking for it. I total is 2. So you multiply both sides by 2. This will get rid of this. And then V2 is equals to 4 volts. Now we know the potential difference across R2, which is 4 volts. There are 2 ways whereby we can calculate the potential difference across this. How can you do it? It's either we can use the very same method, this one, or we can use V total is equals to V1 plus V2. Either way, the answers will be the same. We have V total as it's 12 volts, and then V1, the voltage or the potential difference across R1, we have it, which is 4. Then we can solve for this. So we have 12 is equals to 4 plus V2. V2 is equals to 12 minus 4. 12 minus 4, we have 8. So we have answered the question. I total is equals to 2 amperes. V1 is equals to V1, or the voltage across R1. We find that it's 4 volts, and then V2 is equals to 8 volts. So these are the answers. Our next question, we are given this electric circuit. Now it consists of 2 resistors, which is 1 ohm, and the other one is unknown. We are given that the ammeter registers 0.25 ampere, and then we are given that the voltmeter registers 1.5 volts. Now we also need those basic knowledge. It's positive and negative. Looking at the flow of current, we do agree that there's no branch, so it simply means that the current flowing through R2 will be the total current. That is directly from the battery. Also through R1 will be the total current. Now it simply means that the ammeter registers the total current because there is no branch before the ammeter. So what do we have on R2? So far we have the current, which is 0.25 amperes. We don't have the resistance, we don't have the potential difference. We only have the potential difference of the circuit, the total potential difference or the total voltage. So it's a bit challenging for us to actually directly or simply calculate the potential difference through R2. We have 2 unknowns when you look at the Ohm's law equation. So what can we do? We look at the whole circuit. We have the total current, which is 0.25 ampere. We have the total voltage or the potential difference, which is 1.5 volts. Now let us look. Can we calculate the total resistance? There are two ways we can add the two resistance. Since the second resistance is unknown, we cannot use RT is equals to R1 plus R2. We don't have this, we don't have this, we only have this. Actually, we have R1, we don't have R2. But we can use Ohm's law, which is RT is equals to VT over IT. We have this, we have this. We can find the total resistance without finding the magnitude or the resistance of R2. So substituting RT is equals to our potential difference is 1.5 over 0.25, which RT is equals to 6 ohms. Now from here we can use this equation, R1 plus R2. We know that we have two resistors. Now look, we have this, we have this, we are looking for this. So RT is 6, and then R1 we are given that it's 1 ohm plus R2. Then transposing this to the other side, we have R2 is equals to 6 minus 1. So it simply means that R2 is equals to 5 ohms. We are done with this question. Let us look at the next one. Our next question is a bit challenging compared to the previous questions. Now this one consists of 3 resistors. We are given the potential difference, which is the total voltage, as 18 volts. We are also given the reading on the ammeter, which is 2 ampere. Now there is a question: is this ammeter reading the total current or the current through R1 or R2? That's the question. Now remember, as long as we have series connection only, you must know that I total is equals to I1 equals to I2 equals to I3. So even if you say this current is measuring the current of R1 or R2, you must know that the very same current it's equals to I total. So basically we have the total current of the circuit. So far you can see that we have the total current and the total voltage, because this voltage is directly from the battery. We are given 3 resistors. The first resistance is 1 ohm, the second one is 3 ohms, the third one is unknown. So the questions: calculate the potential difference across V1, V2 and V3. And you must know that V total is not equals to V1, it's not equals to V2. Remember, series connection, it divides the potential difference. So we need to calculate those readings on V1, V2 and V3. Now how do we do that? Focusing on individual resistors. Looking at R1, what do we have? We have the resistance, we have the current, which is 2 amperes. Looking at R2, we have the resistance and also the current, which is 2 amps. And then looking at R3, we don't have the resistance, we don't have, we have the current, which is 2 amperes. We don't have the voltage. Remember, for all of these resistors we are looking for the voltage. Since we have V1, V2 and V3, we need to calculate those. Now looking at the first one, the first resistance, it's simple because we are given the current and the resistance, so we can simply apply Ohm's law, V1 over I. So R is 1 equals to V1 over I is 2 we multiply both sides by 2, so V is 2 volts. V1 is equals to 2 volts. Now going to, okay, we have 2 volts here. Going to the second one, we can apply the very same equation. V3, no, not V3, V2 over I. Our R is 3, and then we have V2 over current is still 2. Then we multiply both sides by 2. This will get rid of this. V2 is equals to 2 multiplied by 3, it's 6 volts. Now going to resistor number 3. It's difficult because we are only given the current. So how can we calculate? Remember the equation, it's V total is equals to V1 plus V2 plus V3. So far we have this, we have this, we have this. Then we can calculate this without actually calculating the resistance. So we have 18 plus V1 is 2 plus 6 is equals to, no, there's a problem here. Let us actually write this. We have 18, it's equals to 2 plus 6 plus V3. From here, 2 plus 6, we have 8 plus V3. We have 8 in this side. When we transpose, V3 is equals to 18 minus 8. Then V3 is equals to 10 volts. I hope you got this one correct. Now moving to, we are done with the first question. V1 it's 2, V2 it's 6, V3 it's 10. Now moving to the next question, which is R3. Now on the resistor R3, what do we have? We have I total, or the current. We also have the voltage as 10 volts. So we can just apply Ohm's law. So R3 is equals to V3 over I. So R3 is equals to V is 10, I is 2. Let me quickly verify. Yes, we have 2. So R3 is equals to 5 ohms. We are done with this question. Our next question is about a parallel connection. Now looking at this, you can see that it's a bit different from the questions we looked at previously. Now this one, we say it's a parallel connection. Consists of 2 resistors, 2 ohms and 4 ohms. The total voltage is 12 volts. Then the question says calculate the total current. We actually looking for the reading on ammeter. Now let us track or look at the path of current. Remember, this is positive and negative. As it moves, we do agree that before the ammeter there is no branch or resistor, so it means ammeter registers the total current. Now when it reaches this point, we are talking about current. It will split. Then when it goes back to this point again, it combines and then it goes to the negative terminal. Now let us look at the equations. Remember, V total is equals to V1 equals to V2 equals to V3. This is for parallel connection, and then I total is equals to I1 plus I2 plus I3. So this simply means that if we have the total voltage will be the voltage across R1, voltage across R2. So it simply means that in parallel connection, voltage doesn't split. So if you have 12 volts, 12 volts, 12 volts, it means Through this resistor we are going to have 12 volts. Through this one we are also going to have 12 volts. That is why the equation says V total is equals to V1 is equals to V2 is equals to V3. I hope you understand. So we have two ways we can actually calculate our total current. The first way, we can just calculate the current through this and the current through this, and then we add them. We know that the voltage across R1 is 12 volts, across R2 it's also 12 volts, so we can use Ohm's law and just calculate. Or the second way, we can quickly calculate, since we have V total, we can calculate R total and then we find our I total. So let us look at option A, or the first option. The first option, we are looking at resistor number 1, R1. We are going to have R1 is equals to V1 over I1. So this one simply means that I'm focusing on this resistor. So R1, it has the resistance of 2 ohms is equals to the voltage we have 12 over the current we have, or we are actually looking for the current. Multiply both sides by current, and then this will get rid of this, and then we have 2I1 is equals to 12 divided by 2 both sides. So I1 is equals to 6 amperes. We are actually done with the current through R1. Now let us quickly calculate R2. Okay, it's V2 over I2. So the resistance is 4 is equals to V is 12 over I2. Multiply both sides by I2. This will get rid of this, and then we have 4I2 is equals to 12. We divide both sides by 4. Then this will get rid of this. We have I2 is equals to 3 amperes. So since we have two resistors and we know their current, then we can use this equation. I total is equals to I1 plus I2. Then we have I total is equals to I1 it's 6 plus I2 it's 3. So I total is equals to 9 amperes. That is the first way. Now looking at the second way, or let's say second option, we can calculate like this. We know V total it's equals to 12. R total we can quickly calculate. Remember the equation to calculate parallel connection. R1 plus 1 over R2. 1 over Rp is equals to 1 over 2 plus 1 over 4. So we get that 1 over Rp is equals to 3 over 4. Then remember, when we cross multiply or we flip change this fraction, we are going to have Rp is equals to 4 over 3 ohms. Then if we have Rp, which means that we have our Rt, then we can quickly calculate our I total. Rt is 4 over 3, V total is 12, and then we're looking for It. And then from here we can just cross multiply or flip change and multiply by 12. So when we cross multiply, we are going to have 4I total is equals to 3 multiplied by 12. We divide both sides by 4. Then I total is equals to 12 divided by 4. We are going to have 3 multiplied by 3, which I total is equals to 9 amps. So you can see that the answers are the same. Let us go ahead and look at another example. We have this electric circuit. The current, or the total current, is 4.8 ampere. R1 is 3 ohms, R2 is unknown. We have our total voltage as 9. In this case, the question says calculate R2. So remember, you can pause the video and work out this question, and then you play the video to verify your answer. Now, what do we have here? We have total voltage, total current, and then we don't have the total resistance, but we can do something. If we find RT, then it will be simple for us to actually calculate the R2. There are two ways. We know that the current will move this direction. When it reaches here, it will separate. I'm talking about I. It will separate, and then we'll combine again at this point. And then when you look at voltage, will not separate. So it simply means that V across R2 is 9 volts, and then across R1 it's also 9 volts, since this circuit is only consisting of series connection only. So looking at R2, we have the voltage, we don't have R, we don't have I. Looking at R1, we have the resistance, we have the voltage, but we can calculate I. Since we have total current, then it is possible for us to actually figure out the current through R2. So we can go ahead and calculate the current through R1. We know that if we have the total current, the current through R1 plus the current through R2 is equals to this total current. So if we have this and this, then we can calculate this. Let us quickly calculate the current through R1 using Ohm's law. R1 is equals to V1 over I1. So R1 is 3 ohms, and then voltage is 9 over I1. We multiply both sides by I1. Then this will get rid of this, and then we have 3I1 is equals to 9. We divide both sides by 3, and then I1 is equals to 3 ampere. So if I1 is equals to 3 ampere, we can find the difference, the current through this one. Now we know that I total is equals to I1 plus I2. I total is equals to this, 4.8 is equals to I1. We have 3 ampere plus I2, we are looking for it. When we transpose, we have I2 is equals to 4.8 minus 3. We find that I2 is equals to 1.8 ampere. Now looking at our resistor R2, now we can say I2 is equals to 1.8. Then we can calculate the resistance, since we have the current and the potential difference across R2. So R2 is equals to V2 over I2. R2 is equals to, okay, we are looking for R2. V total it's 9, and then I2 we have 1.8. We get that R2 is equals to 5 ohms. I hope you got it correct. Let us look at another example. We have our next question. We have R1 and R2. We have the total voltage. We're looking for the total current. Now the first step that we need to do, we can see that we have V total, we don't have I total, we don't have R total, but we can calculate R total. We know that in parallel connection the equation is Rp is equals to 1 over R1 plus 1 over R2. 1 over Rp is equals to 1 over 4 plus 1 over 12. We find that 1 over Rp is equals to 1 over 3. And then when we flip change, Rp is equals to 3 ohms. Now from here we can use Ohm's law to find the total current, which is RT is equals to V total over I total. So R is 3, potential difference is 18, and then we have I total. We multiply both sides by IT. This will get rid of this, and then we have 3 IT is equals to 18. We divide both sides by 3. We find that I total is equals to 6 ampere. Let us look at the next question. This question is a bit different. We can see that this one consists of two different types of connection, which is series and parallel. Now, looking at the direction and the behavior of current, it will flow from positive. Then you can see that here it will split. Once we see that the current splits, we conclude that this is a parallel connection. Then from here it combines, and then through this one there's no split. So it simply means that this one is in series, this is parallel connection. Then to calculate the total resistance, we need to calculate the parallel connection first, then we use the series connection, we calculate. Now looking at the parallel connection, Rp is equals to 1 over R1 plus 1 over R2. 1 over Rp is equals to 1 over 2 plus 1 over 4. 1 over Rp is equals to 3 over 4. And then flip change, Rp is equals to 4 over 3 ohms. Now we can reconstruct this electric circuit. You should know that we have something like this now. Instead of writing the parallel connection, we actually write the series, which this one is the combination of those two. Then the resistance is 4 over 3 ohms, which is this answer, and then this one we are going to have 2 ohms. So this is the new circuit. You can see that the parallel connection is no longer there. Then we can calculate the total resistance using series connection. We no longer have parallel, so R1 is 2 plus 4 over 3. We find that our R total is equals to 10 over 3 ohms. So this is how we actually get rid of one connection, which is the parallel connection specifically. Let us look at another example. This is our next question. We still going to calculate the resistance. Now we see we have positive and negative terminal. It's a bit difficult for one to actually understand the parallel and the series in this case. Now we need to look at the direction and the behavior of the current again. It moves, it reaches this point, it must split, then we can identify the parallel connection. When it gets here, combines, and then through the 4 ohm and then through the 6 ohm, So this is the parallel, and then here we have the series. This one and this one is in series connection. So we need to calculate the total resistance. We start with the parallel, 1 over R1 plus 1 over R2. 1 over Rp is equals to 1 over R1, it's 1 plus 1 over 2. This one we can quickly calculate it. Rp is equals to 1 over 1 is the same as 2 over 2 plus 1 over 2. Then we simply take one denominator, 2 plus 1 it's 3. This is 1 over Rp. Flip change, you are going to have Rp is equals to 2 over 3 ohms. Then we reconstruct the circuit quickly. We are going to have something like this. We no longer have a branch. This is 2 over 3 ohms. This is 4 ohms. This is 6 ohms. So we no longer have a parallel connection. Then we can quickly calculate using our series connection. So RT is equals to R1, it's 2 over 3 plus 4 plus 6. Then our total resistance is 32 over 3 ohms. I hope you got it. Let us quickly look at another example. Our next question is this one. So feel free to pause the video, work out the question, and check whether you understand you can actually answer this question. This one, it's a bit complicated compared to the previous questions. Now we can see we have a combination of two connections. And then the first question is saying calculate the total current. The second one, V4, which is the voltage across the R4 I mean. And then I2 is the current through the second resistor, R2. Now we need to understand something. I believe you can identify the parallel connection. And then looking at the data, we are given the total voltage. We need to calculate the total resistance in order for us to actually answer the first question. So looking at the total resistance, we have the parallel connection 1 over R1, 1 over Rp is equals to 1 over R1 plus 1 over R2. 1 over Rp is equals to 1 over 2. No, it's actually 1 ohm, so it's 1 over 1 plus 1 over 1, which is the same as 2. Then when we flip change, remember any whole number is over 1, so we are going to have Rp is equals to 1 over 2 ohms. So this is 1 over 2. Then we can go ahead and calculate the total resistance, which is R1 plus R2 plus R3. RT is equals to R1, we have 2 plus R2. We take it as this parallel connection is 1 over 2 plus R3 is 1.5. So our total resistance we find 4 ohms. So this is RT. Then we can go ahead and calculate our IT. R total is equals to V total over I total. R total, we find that it's 4. V total, it's 10. This is our 10 over I total. Then we multiply both sides by IT. This will get rid of this. And then we have 4 IT is equals to 10. We divide by 4 both sides. This will get rid of this. We have I total is equals to, it's 5 over 2 amperes. So this is the first question. Now looking at the second question, V4, the voltage across this. Now remember, in series connection, this simply means that this resistor, there's no branch before or after this resistor, or this resistor, it's not on top of, actually it's not one of the resistors in a branch. So it simply means that the I total, or the current through this, is 5/2 amperes. So we can quickly calculate the V, potential difference, using Ohm's law. So using Ohm's law, R4 is equals to V4 over I total, or I4. So we have 1.5, it's equals to V4 over 5/2 is the same as 2.5. So you multiply both sides by 2.5. This will get rid of this. 2.5 multiplied by 1.5, we have V4, it's equals to 3.75 volts. We are done with the second question. We look at the last one, which is I2. Now with this one, we need to reconstruct our circuit. The reason why we need to reconstruct, we must understand something. We are looking for the current across this. The challenge is we only have the resistance across this. The voltage is no longer 10 because we don't have parallel connection only. We have the combination of the two. So it simply means that the behavior of voltage, not current, voltage, remember in series, voltage will separate. The equation, since it's Vt is equals to V1 plus V2. So this plus simply means that the voltage will split. So 10 volts, when it reaches the first resistance in series, when it reaches the first resistor in series, some of the voltage will remain here. And then when you continue, there will be a voltage. Remember, we can combine this to be one resistor. So it means another voltage will remain here. Then the remaining voltage will continue passing through this one. So V1, V2 plus V3, voltage across this plus this plus this will give us 10. So we cannot conclude to say voltage across this and this is 10. No. So after reconstructing, we have something like this. Then we can work out the voltage across this. Remember, this is the parallel connection. I just reduced the two resistors to one resistor so that I can have only one connection. In this case, I only have this voltage, which is 3.75, and then I need to calculate voltage across this one, or I can simply calculate voltage across this one. So from here, I can say R parallel is equals to V parallel over I parallel. I have 1/2 is equals to V parallel over current is 5/2, which is 2.5. So I multiply both sides by 2.5. So Vp, this will get rid of this. 2.5 is the same as 5/2 multiplied by 1/2. So you're going to have 5/4 volts. So this one, this voltage is the voltage across this. Now from here, we can quickly reconstruct and reverse, put back those parallel connections. You don't actually care about other resistors. We only focus on R2, which is 1 ohms, and then this one is also 1 ohms. So we are looking for this. The voltage across this and this is 5/4. 5/4, which is 1.25, 1.25. So in this case, we can calculate our R2. Actually, the question was saying I2, the current. So we have R2 is equals to V2 over I2. R2 is 1, and then our voltage is 1.25. I2 is I2. Then you multiply both sides by I2. This will get rid of this. And then I2 is equals to 1.25 amps. This is the answer. I hope you managed to get some of these answers, if not all of them. That's it for this lesson video. This is Wahula SJ. Thank you very much.